given over here. Design and sketch a Grad bank including launching apron. Maximum discharge is 10,000 cubic decimeter cube per second. HFL, that is high fluid level equal to 250 meter. River bed level 242 meter. River bed material average size, that is the value of D equal to 0.25. So this value given over here, and using this all value we have to design a Grad bank. Okay, so now let's see the solution with the help of previous discussed design criteria. We have to design. Okay, so we follow this design criteria one by one. Okay, so before starting the solution of this numerical, if you are new to the channel, please do subscribe the channel and like the video and press the bell icon so you will get regular updates. Okay, and I have uploaded different video related to our civil engineering as well this irrigation engineering and different numerical as well theory. Okay, and I will keep the link of those in description box. You can visit from there. Okay, now let's see the solution. In very first step we have to determine clear waterway, that is the value of P equal to 4.75 root under cube. This value this formula is given from the Lacey. Okay, and P equal to 4.75 root under cube and Q is given 10,000 cubic. Okay, so this value becomes 475 meter, and for L we have to increase this value with 20% as we discussed in the design criteria first. Okay, you can see here we have to calculate the value of P. Okay, using Lacey's theory. So P equal to 4.75 root under cube, and extra 20% may be provided for the thickness of bridge pier. Okay, you can see this what is bridge pier in figure. For this we have to increase 20% extra. So L equal to 1.2 times P. That's why we take L equal to 1.2 times of P. So this value becomes 570 meter. Okay, and after this we have second design steps. In this step we have to determine the length of upstream Grad bank. Okay, you can see in this figure we have to calculate this upstream length of Grad bank, that is 0. You can see this is the upstream of Grad bank. Okay, and this value is taken from 1.25 L to 1.5 L, from here to here. Okay, and this value becomes 1.25 L. We take, okay, you can take this value between this range. So 1.25 into L, the value of L is already calculated 570. So this value becomes 712.5 meter. Okay, now length of downstream Grad bank. Okay, for this downstream Grad bank we have to use this 0.25 L. So 0.25 L equal to 570 meter. After calculating this value we get the downstream length of Grad bank equal to 142.5 meter. Okay, so you have to show this value in the figure. Okay, so this is 712.5 and 142. 712.5 and 142.5. Okay, so we have to show this all value in the figure. This figure is also very important for our examination point of view. Okay, in the examination we must provide this figure. Okay, with the different parameter shown in figure. So now we have to upstream curve head equal to 130 degree, simply assume, and downstream curve head equal to 45 degree. Okay, and this range is taken in upstream curve of head is taken 130 in between 120 degree to 145 degree. So we just assume 130 degree, and for the downstream curve head we have to take the angle between 45 to 60, and we just take 45 degree. And now we have to calculate the radius of upstream curve head, and this value equal to 0.45 times L. Okay, as you see here 0.45 times L, and the value of L is already calculated, that is 570 meter. So we keep this value, then we get radius of upstream curve equal to 256.5 meter, and similarly the radius of downstream curve equal to 0.25 L. So this value becomes 142.5. Okay, now in third step we have to calculate the cross section of grad bank. Okay, and for this we have already given in question, that is the high fluid level equal to 250 meter. You can see here high fluid level equal to 250 meter. Okay, and this is the high fluid level. Okay, this is high fluid level is given in question, 250 meter. Okay, and let freeboard equal to 1.5 meter. This is the freeboard. We have to provide freeboard between 1.25 to 1.5 meter, as we already discussed in the design criteria. Okay, so the freeboard is taken here 1.5 meter. Okay, and top width equal to 5 meter, as we discussed in design criteria. You can see here freeboard we have to provide between these 1.25 to 1.5, and side slope 2.1, and top width 5 meter. Okay, so for according to design criteria we provide this value. Okay, freeboard 1.5 meter, top width 5 meter, and HFL this is already given in question. Now we have to calculate top level of grad bank. Okay, simply you can calculate this top level of grad bank. Okay, this is top level of grad bank, and this value simply calculated by adding this freeboard in this HFL. Okay, and you can say the value of HFL is given in question 250 plus freeboard. Freeboard we have already assumed 1.5 meter. After adding these two value, this value from here to here, and freeboard from here to here, so we get overall depth. Okay, from here to here, this value becomes top level of grad bank becomes 251.5 meter. Okay, so this top level becomes 251.5 meter. Okay, so we already calculated top level of grad bank. Now we have to design stone pitching and apron. So depth of water above the bed level, this value depth of water above the bed level, for this y value we can simply calculate this value from subtracting the river bed level, this level minus from HFL minus this level. Okay, after so minus this river bed level we get the value of y. Okay, so y becomes 250 minus 242. Okay, this value is 240, and this bed level is given in question 242. Okay, and after minus this 242 from this value we get the value of this y. Okay, so the value of y becomes 8 meter. Now we have to calculate the height of a bank above the river bed level. Okay, and the height of the bank above the river bed level. Okay, you can see here this is the river bed level. Okay, and now we have to so for this you can see this is the bed level of river. Okay, river bed level, and this is top width, and this value is 251 meter, and this value is 242 meter. Okay, now we have to calculate this value. Okay, and you can see this value is height of bank above the bed river, the height from here to here. For this now we can simply calculate by minus this this is the 242. Okay, and we have to minus this 242 from this value 251 minus 242, then we get distance from this point to this point. Okay, so the height of bank above the river bed equal to 251.5 from here minus 242 at the bed river bed level. Okay, then we get the value of height of bank equal to 9.5 meter. So this value becomes 9.5 meter. Okay, this is the height of Grad bank. Now we have to calculate the slope pitching thickness, that is the value of small t. This small t we can calculate small t equal to 0.06 times of q to the power 1 by 3, as we discuss in design step number 4. Okay, value of small t, capital T and L, as discussed in previous. We have to calculate this all parameter. So for this we use discharge equal to 10,000 and the slope pitching thickness, that is the value of small t, becomes 1.3 meter. So we have to provide 1.3 meter side sloping pitching. Okay, so this thickness t equal to 1.3 meter. Okay, so you have to show this value in figure. Okay, this is very important. We have to provide different calculated data over here in this figure. Okay, and in exam you must provide this figure with this different calculated value. Okay, now we have to calculate thickness of apron, that is value of capital T, this capital T, and this value can be calculated using this formula 1.9 times T, 1.9, and the value of T is taken 1.3. This value becomes 2.5 meter. So we have to provide capital T equal to 2.5 meter. Okay, you have to mention in this figure, and so provide thickness of apron equal to 2.5 meter. Now we have to calculate length of apron, that is L equal to 1.5 times of D. Okay, and for this we have different two condition. As we discussed, the length of apron can be calculated equal to 1.5 times of D, and the value of D is taken 1.25 r minus y for the straight, and D equal to 1.5 r minus y for the curve linear. So we have these two conditions. Okay, and we have to calculate these two conditions individually. So for straight this Grad bank, we have to use this formula, D equal to 1.25 r minus y. Okay, and value of y is already known, then that is 8 meter. We have already calculated the value of y equal to 8 meter, as I this. Okay, the value of y equal to 8 meter. So you have to show this value also in the figure. So this value is 8 meter. Okay, so simply say this is the 8 meter. That is the depth of water above the bed level. Okay, and now we can calculate the value of F equal to 1.67 root under D. And what is D? D is the size of silt particle. Okay, and the size of silt particle in given question equal to 0.25 meter. Okay, so we just use this value 0.25 meter. So the silt factor Fe becomes 0.88 meter. Now we have to calculate value of 0.47 root under Q by F to the power 1 by 3. And Q is already 0.88 after calculating this value. Okay, and this value gets 10.56 meter. And now we have to calculate D equal to 1.25. Okay, then we get the value of D equal to 5.2 meter, and length of apron L equal to 1.5 D, and D is taken 5.2 meter. This becomes 7.8 meter. Okay, so you have to write here this is the length of apron, and this becomes 7.8 meter. Okay, this is for the length of apron for the straight this Grad bank. Okay, now let's see whenever for the curve linear transition portion of Grad bank. Okay, and now we have to calculate this value, that is 11.76. You have to show in next figure. Okay, this figure is for the straight this Grad bank, and for the curve linear transition we have to make same this figure in another. Okay, so you have to make two different figure. Okay, but for now I will show these two value in this figure. Okay, and after calculating d equal to 1.5 r minus y, r is the value is 10.56 minus y is 8. This value becomes 7.864. Okay, only the value of d is changes. Okay, in above this value is 5.2 and in this this value is 7.86, and we can calculate length of apron L equal to 1.5d, and we use this value, so the length of apron becomes 11.76. so length of apron becomes 11.76. okay, so we have to provide this two different value in two different figure. Okay, provided in this figure. Okay, but you have to provide in two different figures. Okay, so this is of Grad bank, or you can say this is all about this numerical. Okay, thank you very much. See you in next video. If you like the video, please do subscribe the channel and like the video. Thank you very much. See you in next video.